Hi, welcome to Learning Monkey. I am Raghuveer. Please watch this video till the end and share it with all your friends. In our previous videos, we clearly discussed that a computer science student, if he wants to have a good intuition or deeper understanding of the basics of computer science, yes, compiler design subject, it is must to study the compiler design subject to get a good intuition about computer science basics. And we also discussed in our previous videos that if you want to study compiler design, the basics to study compiler design is theory of computation. So first, if you are not good at theory of computation, please watch our playlist theory of computation, complete it, then come to compiler design. You can check our playlist. You can study any subject related to computer science at Learning Monkey. So now in this video we are going to understand, we are going to have a good understanding, basic overview of what's the role of compiler design. So we will discuss few points. Keep these points in your mind, then start studying compiler design. These points will help you a lot in understanding the subject properly. So coming to the role of compiler, the role of compiler is converting high level language to machine level. This is what compiler is going to do. So in this conversion of high level to low level means machine level, it will follow few steps. So our subject also deals in the same way, whatever the steps it is going to take, our sessions also divided in the same way. Let's try to understand what those steps, how they are related to theory of computations, which part you have to concentrate, all these things we are going to discuss here. Now coming to this, we'll take an example and understand step by step what's the syllabus is going to cover. So how the syllabus will be. In the first session of the compiler design, let's take a high level language example. We are going to take C programming, main of int a is equal to 0, b is equal to 5, semicolon, int c, semicolon, c is equal to a plus b, z is equal to c plus a, printf percentage d z. This is a high level programming language. We are taking C programming. You can take any high level programming language. The role of compiler is to convert this high level programming to machine level instructions. Whatever the instructions we studied in computer organization and architecture, this instruction should be converted into add instruction in computer architecture. This instruction, see, printf z is equal to c plus a, store instruction, you have to do addition and the result should be stored in z. Store instruction in computer organization and architecture. How this high level language is converted, the first session is going to deal with, see, the compiler in the first phase, it is going to check the character by character. It is going to read whatever the program you have written. That program is, the compiler has to read the program character by character, first character, second character, third character, and it has to group those characters into tokens. The word token from our C programming language, tokens, identifiers and keywords. So tokens, it has to divide it into tokens. Means MAIN, it has to read, make it as a token. Open brackets, it is a token. Closed brackets, it is a token. Flower brackets, it is a token. Int is a token. A is a token. Equal to is a token. 0 is a token. Comma is a token. Like that, it has to separate first. Means it has to study, it has to read the characters one by one and separate it as tokens. So how it has to read, how it is going to separate it as tokens. This concept is so it is going to be explained in our first session. For this, you have to have the basics of finite automata from the theory of computation. Whatever the concepts we discussed in finite automata, those concepts we are going to use those concepts to write the program for identifying the tokens from the given program. Theory of computation, we already provided in finite automata the programmatic intuition of finite automata. Using if-else statements, we are going to implement finite automata. So with that programmatic understanding, whenever you are studying the concepts of compiler design, think in the programmatic way. That helps you a lot in improving your knowledge. That's why in theory of computation we explained how this implementation is done using if-else statements. Simple example we explained there. So finite automata helps you in understanding this first session. Once it is divided into tokens, the second session is going to deal with each line is syntactically correct or not. That is what it is going to deal with in the second session. Means the first token identified is main, after that open brackets, after that it's closed brackets. So this line is syntactically correct, like that second line, like the third line, int a is equal to 0, int space a equal to 0, comma b equal to 5, semicolon. This line is syntactically correct. So syntax evaluation is done in the second session. How it is going to do syntax analysis, that we are going to discuss in the second session. In theory of computation, context-free grammar, we discussed the concept. So how this syntax analysis is done, that is done using context-free grammar. In our theory of computation, we provided the programmatic intuition of context-free grammar also. How we are going to implement context-free grammar using recursive functions, calling function within the function. Using that concept, we are going to implement that. So if you are good at theory of computation, understanding this is very, very easy. Once syntax analysis is done, then it is going to go with the third session. Third session is going to deal with the programming language condition check and conversion to machine language, machine level language. Programming language condition check. What's that mean? Programming language condition check. From this program, it was our compiler clearly identified this program is syntactically correct. But this is not enough for compilers. Each programming language have some conditions. Different programming languages have different conditions. What's those conditions? Let's try to understand with simple example. See, in our C programming, Z is equal to C plus A. What's the condition for the C programming? If you want to use a variable, it should be declared first. Is it declared first? No. So it is not allowed in our programming language, but this is allowed in Python. The conditions changing here for programming language to programming language. So what's our programming language conditions? Is our program maintaining those conditions? Those conditions will be checked in our third session. So in the third session also, from the theory of computation, context-free grammar is going to be used to identify those conditional checking and type checking, all those things. So that's why context-free grammar and finite automata helps you a lot in understanding the concepts of compiler design. After that, how this high-level programming is converted into machine level. This is also done using the context-free grammar. The same concept. Once this high-level programming language is converted to machine-level programming language, the fourth session is going to deal with optimization. Means the machine-level language, we can optimize that machine-level language according to your computer architecture, whatever the processor you are going to use. Based on the processor, each processor is having some advantages. So how to use that advantages, how to optimize the code, what are the situations you go with optimizations. These situations will be discussed in our fourth session when we discuss about optimization. So these are the steps to convert from high level programming language to low level, means machine level language. So based on this intuition, keep these points in the mind and start studying compiler design so that you will have a good understanding. If you are not able to catch the concepts, means you are not good at theory of computation. So that's why you have to go step by step. Check our complete playlist, how to study computer science playlist. You are going to understand how you have to start computer science and you have to go step by step to improve your basic understanding on computer science. Thanks for watching. Please do subscribe to our channel and press bell icon for the latest updates. Thank you.